can see what's going on here. This red graph is the graph of the parabola x squared equals 2y, or y equals 1/2 x squared. So any point on the parabola will have an x coordinate of x, let's say, and the y coordinate will be 1/2 x squared. And the distance between that point on the parabola and the point 4, 1 can be expressed or determined using the distance formula for the distance between 2 points. Before I start talking about finding that derivative, let's just look at what's happening here. If I use that distance formula for any arbitrary point on the parabola, you can see that the distance to the point 4, 1 definitely changes, and that there likely is some point on the parabola that's closest to the point 4, 1. The question is, where is it? And we can find that by finding the first derivative. So I've rewritten this distance formula with an exponent of 1/2. You could expand these binomials and take the derivative that way, but I'll do it using the chain rule for the inside. So bring the 1/2 down front. The expression in the brackets, the exponent's reduced by 1 to minus 1/2. And now on the inside, using the chain rule, whoops, these parentheses shouldn't be here. Not sure why that one's there. That one. Okay, so we'll bring the 2 down front, reduce the exponent by 1, 2 times the quantity x minus 4, plus bring this 2 down front, reduce the exponent by 1, multiply by the derivative of the inside, chain rule, 2 times 1/2 is 1, so we've got an x there. Okay, so now if you rewrite this with this radical in the denominator, set it equal to 0, and by the way, this is what you get after you start simplifying. The 2x and the minus 2x combined to 0. After you've done a few of these, you start to realize that when you set it equal to 0, it's only going to equal 0 when the numerator equals 0. And so we could have just concentrated on what's under the radical. But if we set the derivative equal to 0, we get x cubed equals 8, x equals 2. And when x equals 2, 1/2 of 4 is 2. So the point 2, 2 is the one that's closest. We should probably apply the first derivative test to show that it's actually a minimum distance. So 2 is the only critical number. If you pick a number to the left of 2, like 0, plugging it into the derivative, you find out the derivative is negative, so the original function is decreasing. To the right of 2, the numerator is positive, so is the denominator, so 2 generates the minimum. And so if I come back to Desmos and change x of 1 to 2, there is the minimum distance, 2.236068. That's approximate. There you go. Hope that helped. If you have any questions, post a comment.